Hello, my name is Brian Loomis, and I'm with Progress Chef. I'll be speaking with you today about the practicalities of using OpenTelemetry and telemetry in general to provide feedback, given business metrics, and on operational systems. We've built a prototype, which I'll share with you, based on some specific needs of operating a software as a service, SaaS service. Logging and tracing are fine for small numbers of customers and for direct developer interaction debugging, but they have some limitations when it starts getting into larger systems, and especially with regard to understanding customer behavior within the context of what they're licensed to use, and maybe some limits on those licenses, and with automating the scalability of large clusters of services, right? So when we get really big, those logs get similarly big, and they actually can't really drive as much sort of high-level behavior. Recognizing that OTel and OTel-like systems have some press out there indicating they're hard to implement, we found it pretty approachable, and we'll try and give you some idea of the specific types of metrics we're trying to collect, how we're using tracing and events to make those actionable and to achieve superior performance on our services. Let's take a look at what's coming up. As a quick agenda, we'll talk about topics in roughly this order here. A little bit about traditional one-way telemetry and some of the challenges we're hoping to overcome. We'll talk about our design with feedback loops included. There's a key concept in there that the telemetry is going to drive some other services and other events elsewhere in the system. Our example application, how enterprise systems work, and what we need from a licensing and business metric perspective to show back to the customer or our tenant in SaaS. And then we'll wrap up with some final comments. The data we've collected through telemetry is pretty important in driving two very important pieces of the business. One is obviously revenue, and the other one is customer satisfaction. Those two are pretty tightly coupled, right? Our solution, the Chef360 system that we're putting this into, is a multi-tenant SaaS application, right? Meaning we have multiple organizations, and each of them may have one or more tenancies, or I would say operations and data subdivisions to them. And the whole solution operates on a consumption-based billing model, right? So truly as a service that you order up a certain quantity of operations that you want to achieve. Fundamentally, we want the SaaS customer to dynamically change their demand proportional to where they see value. In DevOps, this means going from a limited prototype, evaluating functionality and maybe some candidate workloads in a limited capacity, to increasingly broader use across the enterprise, eventually having the most critical systems under management. Often this is tens or hundreds of thousands of machines to us. The customer buys in incremental workloads of the operations they perform, seeing value in new cases as the system adoption grows, as they add more machines, as they add new types of jobs, in our case. This presents unique challenges to the standard MELT model of how we traditionally look at logging, right? Events are usually tied in that model to very smaller than business increment type operations, right? So maybe an API usage, but not necessarily a single operation that the customer is paying for. Or they're very strongly correlated with the logical implementation and not the business value. Meaning that sometimes we're tracking events and logging based on an API, but that's not really what the customer is paying for. We may be tracking things on a CPU basis or a disk space basis, but the customer may be ordering in very different units. Tracing similarly is constrained often to non-production debugging because it's so verbose. And even that logging is often too voluminous to support any actionable insights for either the service provider, our team, or for our customers. And the final issue that we were facing was really that we're not being responsive enough at scaling for large numbers of tenants, right? We'd often have to have them wait for a little while until we provision some more hardware or whatever it happened to be. So there's a delay between when they want to scale up their demand and when we actually provision the demand. To address this, we developed a telemetry-driven approach that provides visibility into the license features and the number of operations, maybe the demand quantum that the customers ordered. And that enables us to dynamically scale our workloads, and it also enables us to bill very accurately. So I'll keep going here. This is a typical, maybe an enterprise application lifecycle, and certainly true for enterprise grade SaaS applications, right? A customer is going to purchase a tenancy in the application through maybe a license or a transaction in a ERP system. They may install the app. It may be hosted in the hosted SaaS service, or it may also be available on-prem. It may be in their cloud, right, through an AWS marketplace or an Azure marketplace, or maybe in an air gap environment, even further removed from maybe internet accessibility, right? Now, for your application, you want to have your application behave the same way everywhere, right? And so that's going to be one theme that we see coming through this, is that our telemetry structure is exactly the same, whether any of these cases are true. If the application is multi-tenant like ours, then there possibly is more than one tenant per organization, right? A customer may have a tenancy for maybe manufacturing in Asia and one for manufacturing in Europe, and they may be separate, possibly the same org. But also, more likely, there are going to be multiple tenants in there from different organizations that need really significant privacy and security walls between them. And so one of the keys also is that our telemetry can't bleed through from one customer to the next customer, and maybe not even between one tenant and another tenant within the same customer. Once provisioned, each tenant is going to have users which perform their operations, right? The license may grant them a certain quantity of these, and as a service, right, you're ordering on demand in billable chunks, maybe tranches, or maybe by feature set even on whatever they'd like to purchase, right? They may want this feature, but not this other one. And that may change over the lifetime of their license, right? It may be updatable. If you're thinking in-app purchases, yes, that's certainly true. Probably bigger things than Candy Crush power-ups, but maybe more like DevOps minutes in our case, in Chef360's case, by the thousands, right? So you may order in chunks of big computing power. These are some of the events we want to capture, right? We want to know what these are, and we want to translate them into metrics to show usage over time. We also want to know how the system, the underlying system, is performing when this increased load gets put on it. So we're going to take metrics on the average load. And that could be as simple as Kubernetes metrics. In more complex terms, we call these aggregate events, and they inform our customer usage thresholds. It goes back to the customer, tells them, hey, you're licensed for 500 units. You're getting close. We're going to throttle you down as you get closer to that. Maybe you're at 95% of your capacity, and you're going to hit a limit there. We'll also show that back to the customer on a dashboard that brings these OTel events and metrics back to them for full transparency control from their side, right? We want them to see the workloads in business terms, right? We want to see it in units of measure that they're buying, not necessarily what we're charged as the service provider, right? We may be billed for CPU minutes or disk space or something like that, but the customer is actually buying something that's different, right? They're buying a capability in business terms, right? They're buying DevOps minutes or number of jobs. We typically bill in Chef360 by a logical job running on a customer node, which we call a job node, strangely enough. Okay, and that's our per instance measure that they can scale up or scale down, right? They don't necessarily care how many EKS containers are running in the background or anything like that. We want to abstract our platform cost effectively from what the customer's actually buying as a service, right? So why don't we do non-OTel type solutions, right? Why do we go to the extra trouble of adding OTel in here? And so our typical scenario that we're dealing with, we say like enterprise grade solutions. Imagine you have a customer that has 100,000 containers that only last for a few minutes each. It's a very dynamic environment. It scales up and down very quickly. Some of those particular nodes that we would call them execute very quickly, and then they disappear, right? They get dehydrated, or they're ephemeral, as we call them. These are some of the questions that we realize that we're asking ourselves as we're going down this OpenTelemetry journey. And why OpenTelemetry? You think of like how many times you've just shipped a system to production that has had debug tracing turned on. You're like, just in case something goes wrong, I'm just going to turn on all the logging, and we'll scale it down if there's a need to scale it down and just take less logs. But we're designing for the doomsday scenario where we have to have all the logging all the time, right? And this gets worse, obviously, with distributed systems because you have uncorrelated logs, right? You have to bring them all together somehow that may have come from different time zones and they're interleaved. Might call this Datadog diving. I don't know. I was making that one up. But also we have to realize that someone's going to have to look through all these logs, right? So even though we may be taking in a lot of trace information, a lot of debug on every API call, on every request, every response into the system, fundamentally at the end of the day, your developers are then your tier 3 support, right? If something goes wrong, the developers can have to look through this massive data and try and intuit something about it. I would also argue without an intelligent assistant on that or some way of parsing that, that becomes really unscalable really quickly. Imagine you have 100 customers that are feeding into a SaaS service log, figuring out where that one customer was when they had an issue is looking for the proverbial needle in a haystack, right? How many times have you just bolted on events every time an API is called, right? And every time an endpoint gets hit, you may be logging an awful lot of data, but you're also probably logging the request and the response. Do you go through and actually take the time to apply privacy filters to that export, right? Before it gets out to maybe the service provider or something like that. And then many times when we go, oh, customer, you just go ahead and collect all the logs, and then you implicitly tell us that we can see everything in those logs, and you just ship them to us, you zip them and FTP them over to us, and we'll take a look at them, right? It's a very asynchronous process, but it also doesn't provide any privacy. And in a multi-tenant environment, this is very important because we're going to want to do things like auditing events and show the customer who had access to do what thing at what point in time. And we're looking at a multi-tenant log scenario, unless we've parsed them out by tenant. The other one we run into a lot is how many times do you then go, okay, I've got this big body of log files. I'm going to have to put a reporting solution on top of it, right? I've got to build a dashboard. I've got to do all this stuff. And then you realize, oh, wait, there are tools out there and other people seem to be able to do this a lot easier than I'm able to do it. And then you go, okay, what if that log file isn't actually answering the question, the fourth bullet on here? What if that telemetry is not useful to the rest of the people in your organization? It's useful to developers maybe to troubleshoot a particular debug instance, to find a bug or something like that. But what about the next time the customer comes up for a licensing discussion and you want to be able to show them, hey, you've been using 80% of your allocation. Do you want to buy another 10% or something like that so that you have enough capacity to grow? We're not collecting those metrics. What we're collecting is a lot of very low level APIs, right? And this drives some very particular customer behaviors. I put a couple in here. The customer may overbuy, in which case they're spending a lot of extra money on their solution, which kind of looks like shelfware to them, right? And they go, ooh, maybe when budgets get tight or something, maybe I actually go in and evaluate like how much I'm spending on this solution over here. Or they have even worse behavior that they limit themselves and they go, well, I don't want to go back to procurement and add another quantum of things. And so they're taking themselves, like they're constraining their own value because they can't see how much they're using of that solution, right? And they don't want to go over because that would be very difficult organizationally. And they'll not even ask you the question of, could I get better service, right? And so both of these, when I say the business metrics get impacted and your revenue as a service provider gets impacted because the customer's holding back from the conversation you really want to have, which is, can I pay for just what I'm using for? Okay. And then in the last one, it's more of an operational concern. We call this the horizontal pod auto scaling only gets you so far. What do you set your pod sizing to? If you're adding multiple customers in there that are variable size and may get bigger over time and may eventually either themselves or the combination of these customers may exceed the reasonable size of a cluster, right? You have vertical pod auto scaling. You can add more physical nodes. You can get monolithically bigger, but how do we actually get real auto scaling that can burst out? Here we're sharing the architecture diagram behind our solution, showcasing a multi-stage telemetry processing basic dashboard. On the far left side, you'll see the licensing service, which talks to our tenant provisioner service, which then allocates capacity in one of many, potentially many Kubernetes clusters for the new tenant based on current usage or requested usage. If the customer gets larger, too large for a single cluster, we want them to burst to the next available cluster and have that automatically be created for them. Telemetry is captured identically on-prem, as in our SaaS service, multiple clusters will feed into a local telemetry dashboard for a single organizational customer. This is then optionally anonymized and fed to a global hotel collector operated by Chef in progress, which allows our organization to monitor any on-prem clusters which opt in and all of our own SaaS clusters. There's three things to note with this. Really, the first one is the lines backwards going between the local collector and the provisioner allows for feedback when the cluster gets full at capacity and causing a new cluster to be spun up and new workloads then to be allocated to that new cluster, cluster number 2, for instance. And then the second piece of feedback there is the global collector can send a signal back over billing to tell the customer they're actually close to exceeding their contractual limit and see if they want to upgrade their licensed usage. The third thing to note here is that basically we have the same tiered pattern for any customer type. Our helm chart does not change if we deploy on-prem, in air-gapped, or in customer supplied cloud, or cloud hosted by us. It's the same exact pattern. The customer would get on-prem everything up to that orange local customer telemetry dashboard. And then we would still have some of the global services wrapping this. But otherwise, they get everything in the middle of this picture and they operate exactly the same way. And they can see all of the telemetry that they want to see. This sort of talks a little bit about the sample application that'll be out there. This is just a sample hotel implementation. It's roughly equivalent to the prototype that we're using. It shows all the items that are in the diagram just before this. And really the difference is here in the bottom bullets there. Our application, our main application is a bunch of Scratch containers that are written for AWS EKS. They're in Golang. And so our hotel implementation is in Golang, not in .NET. .NET seems to be an easier one to present to people and has a really good walkthrough and everything. You'll be able to download the code samples from the repository and the references here. Just quickly go through this. There's a client tool that asks for jobs to be submitted that basically runs for multiple customers, simulates demand into the system. The ones in parentheses I'm not supplying, they would typically be part of this service, but a routing service or a load balancer basically that takes those client requests and puts them in the right clusters where that job was deployed. Right? Obviously, we'd have to talk to the provision service to go, okay, where did customer with tenant A and this particular workload or license go to? Oh, that's over in cluster 5. Right? So that routing service we leave as an exercise to the reader. We have the job service, which takes client requests and may have some limits implied, right? So it goes, okay, you are only licensed to do 5 operations. So we'll cap you at that point, and then we will not take requests after that point. But it also has its own internal capacity, right? So that once it gets full, it's expecting that the load balancer or the provisioner is going to redirect all that load to a new cluster. The cluster management service itself, I just talked about that, which will provision new clusters once at capacity or near capacity. And then finally, on the outside, the observability platform that you might bolt onto your telemetry service might be a Prometheus or a Grafana or something to visualize this so that an operator can go, okay, what's actually going on in my cluster? Might bring in the Kubernetes metrics as well, CPU, disk, network load, things like that, as well as the business metrics that we're getting from the hotel side. Okay. Coming over here, I wanted to show you just a quick animation here, and I'll see if I can play this video here. I did this in ChatGPT, so apologies for the simple nature of this and everything. I put the prompt in the repository as well, so you'll see that out there if you want to do your own animations and things like that. This basically shows a red and a blue customer, each with a limited number of jobs that they have. Eventually, the starting cluster gets full of requests and bursts out to a second cluster. And you'll see that blue eventually goes, oh, wait, I'm limited by number of jobs. I don't want to have to wait like red customer did to start my next one. I actually just want to go ahead and bump up my license, and you'll see all of blue's jobs then come in. So I'll just play this quickly for you here. There, Red has to wait before he can submit his next job. Red wanted a total of 8, so it's done for right now. Let's see what Blue does. Blue asks for 5 more, has a little more space in there. So his are just going to go into cluster number 2, which is a little bit bigger size than maybe cluster number 1 was. And there we go. Blue is done. There we go. So I'll talk a little bit here about the differences between where we were, our legacy solution, and our new solution, and especially the types of metrics that we're able to track right now. And I apologize, just probably blow this up on your screen to see a little bit of the detail and everything, because there was so much stuff that we really added in here. Really 3 big things to note here. One, we're using tiered OTel collectors, right? So one set of collectors will forward those with OTLP, over to another, the global OTel collector as well, right? Gives us a chance to anonymize data before sending it on to the next stage of processing. Also lets the customer who's in control of that local one to opt in to letting us see some, none, or all of their data. Having that local on-prem collector lets the customer also manage their own telemetry, but if there's an issue, they can change how much they're sending us, right? And then we could be opted in to help troubleshoot, and then they can dial it back when they're all clear. And the third thing to note here is that the business metrics of job nodes, the sizing of a job, right? Our sort of quantum, the little red and blue dots from before, right? How big or small it is compared to the capacity of the cluster, lets us decouple the actual cluster that the customer is running on from the service that they're buying, right? They're buying a set of those dots. They're not buying whether it's in cluster number 1 or number 2. They may be on a portion of one cluster and maybe in there with other tenants that sort of fill it up, or they may span multiple clusters because they've gotten very large, or they may even decide that they want to move some workload and expand on-prem or vice versa from on-prem into the cloud to gain efficiencies. That way, the customer is paying for the operations they need, not more or less. Okay, so can you do this in logging alone? You can. I think for all the questions that we brought up here, logging is certainly an easy solution, but it does have a couple drawbacks. One's that you're going to have to write some code, some bits around that OpenTelemetry really gives us for free. It doesn't help us, for instance, when we get to implementing privacy and auditing. The logs are low tech, right? They're shared between organizations at a very granular level. You want to be able to get rid of privacy, PII in there. You want to be able to provide traces for debugging. You don't want all the other noise that's going on from maybe other tenants and the infrastructure, even if they are from the same organization. Telemetry processing could give us that, right? And can aggregate some of the things that we would normally track as 5, 10 different API calls in a row to go, that's one count on a business metric. That is one operation that we would bill you for. Basically helps us as a SaaS provider as well, isolate customer data from each other, right? So that helps as well because we'll have a little customer ID on there. The other thing is that, remember we talked about customer buying behavior. We don't want them to behave irrationally, right? We don't want them to overbuy because they're afraid they're going to run out. We don't want them to limit their usage because they're afraid they'll run over in terms of billing, or they'll have dynamic billing applied to them. We provide customers basically a flexible mechanism that they can buy chunks of, quantum of operations, right? So you can buy 500 or 1,000 or in chunks of reasonably useful increments, but then that set of increments mirrors their actual usage, right? So they see steps up in their licensing. It's not a gradual curve or any sort of performance realm where they maybe submit a giant job in and then they realize, oh, that wasn't the job I wanted, and it spikes their load and we don't have a way to go, wait, let's hold off on that one and have that discussion with the customer and go, is that really what you wanted to do? And get them into the plan that they're really looking for. What we don't want to have is a mismatch between billing and what value they're actually seeing, right? And so the business metrics give us that aggregation, that abstraction. Okay. And then finally, of course, on the troubleshooting side, our operators already knew with our previous implementation, having 100 customers in the same logged cluster, it's tough to follow a single logical operation through that, right? Much less through one server. But then if you think of 30 or 40 containers where you're having to aggregate, cross them, and trace between them what really happened, then you don't want to bother the other 99 customers in that cluster. Okay. So some technical notes on the prototype here. We're using simple OTel emitters and collectors. The local collector is followed by a global collector again. Each of those is a container that can embellish those input events, the tracing and the metrics, and create other events as part of feedback to the manager processes, like provision and billing. Decoupling our cluster capacity from the logical customer deployment helps solve the HPA only gets you so far problem. Horizontal pod auto scale, right? If a customer needs 500 scale units and we can only get up to 100 per cluster, then our provisioner knows that he has to put another floor out there. There's some things we don't do yet, right? So there's some things that we'll be totally transparent with. Moving workflows between cloud and on-prem. That's tricky. That's not an easy thing. It's not something that Hotel necessarily gives you out of the box. Pinning allocations from that provisioner to specific clusters. Say you need to stay in a GDPR region or have some special licensing like that. Or also putting true AI in there or maybe machine learning to make intelligent provision choices. Those are all areas for us to grow. Again, to summarize new versus old, this is at the business level here. We're using tiered OpenTelemetry. This helps us grow with our customers in a very transparent way. We have the same code base for on-prem as our hosted service. And it's a multi-tenant solution where the customer sees their own dashboard and controls how much they want us as a service provider to see. Between this and another complementary on-prem solution, we can bring business metrics together with the customer licensing and Kubernetes performance data to show a more complete picture back to the customer so they can take their own appropriate action and really self-service based on what they want to use, right? Isn't that the whole purpose of telemetry? And finally, I'm going to say we picked OpenTelemetry. There are a lot of other solutions out there, Prometheus, Datadog, Splunk. A lot of these will enhance logging to a great degree. We didn't want something specifically that would add extra load onto the services that we're doing. It had to be something that was native in the service, that it could emit telemetry, but it wasn't an extra burden to have on there another, either a pull mechanism or an agent of some sort that's on there that's also running, right? And wasn't really, I would say cloud native, but really not container friendly, right? So finally here, this shows some resources for the talk. An OTel getting started in .NET, really easy, takes 5 minutes. An OWASP logging checklist. So if you haven't been out to the security site and seen what you should log and what you shouldn't log, it's a good example of what the security folks might ask for. And our repository for our .NET sample, the one that I wrote, and that'll be available by the end of the month. If you shoot me your email, I'll notify you directly. Otherwise, just follow the space and you should see the update when it hits. And then finally, the documentation of the Chef360 system, if you want to understand some background of what we don't want to talk about jobs and runners and things like that. Okay. And that actually should be GA within days of this talk as our hosted service. So we're pretty proud of that. Finally, thank you for listening to this talk. We wish you a very helpful and inspiring Conference 42 from Brian and Chef. Goodbye.